Good morning. My name's Alison, and today I was thinking I might have a talk about why so many teachers talk to me about the idea that students struggle with fractions. Now, fractions for adults often seem like a relatively simple concept to learn. However, I think one of the main things that people forget is that fractions actually use three models to help students understand them in three different ways. And they are used for 5 different reasons. And if students only understand one or two of those constructs or the ways we use fractions, then when they are faced with questions that are phrased differently or hold a different conceptual idea of fractions, they often struggle to see how a fraction relates. And so what we find is that students, when they're in the early years, learn about the part-whole version of fractions, and they learn about the area or region model of fractions, which is, in essence, that fractions are able to be modelled by seeing them as 1/4 of a shape, for example, or 1/2 of a shape, which is a very strong starting point, and it is one of the most commonly used ways that we use fractions. The difficulty comes with the fact that later in their primary school and high school journey, they need to know about fractions as quotients, or fractions as operators, or fractions as ratios, or the fifth version. The issue becomes then that when we say 1/8 of something, which is the operator construct, many students who haven't fully grasped the different ways you can see fractions start to be uncertain of how to do that. They try to do it the same way that they've done other things. So they'll create a fraction that is 2/28, or other generalizations that they've created. And so this means that as teachers, we need to be very aware that we have to give students opportunities to use fractions in those early years when they're coming to grips with them in all three models, which are the area model, the linear model, and the set model. So the set model is when we have a group of things and we show that 1/4 of a group is still 1/4. So if we have 20 marbles, taking out 5 of those marbles means, or circling them, putting them in a bag, any of those things that show they're still part of the set, but they are the section we're looking at, allows them to make the link later on to the idea of operators. So we're looking for 1/4 of a set of 24. If they've used the set model, that's a much easier concept to understand. However, if they've only ever used the area model, where there is one whole thing and you have to break it up into 4 parts, then understanding the operator construct is very difficult. So there are some things we need to think about. The first is that as teachers, we need to understand what each of the models are. So we are all fairly familiar with the area or region model, but again, there is a difference in those. So one is the region model, which says that 1/4 of something, that section in the corner, is 1/4. But the area model says it doesn't matter where it is. It could be chopped up into little pieces, but the area of those pieces always has to equal 1/4. And again, this is a differentiation that many students don't understand. If they see a fraction and they see that there are 2/8 that are in red on a flag, for example, they don't see that as 1/4 because they're separate. So we need to give students opportunities to compare different ways that fractions look, the same fraction. So we need them to understand that 1/4 looks like 1 out of 4 matching sets, but it also looks like 1 out of 3 sets where 2 of them are the size of 1/4 and 1 of them is the size of 1/2. The issue becomes that we don't do that at the beginning. This is a developmental learning. So as students build up, at first they can't look at quarters as anything other than 1/4 of one whole, because this is a brand new concept. But by the time they're in year 3, then they should be starting to think about how that looks. They should certainly, in years 2 and 3, be starting to look at the set model, where we have a group of things and 1/4 of them, we can make them into 4 equal groups, and therefore we will have that information. One of those 4 equal groups works. So we talked about the idea of 3 models. And I think it's important that we talk about how to teach the models. So the 3 models are the area or region model, the set model, and the linear model. Now, the linear model has a really strong link to using rulers later on. It had tape measures, all of those things that we measure in a straight line. So using streamers or ticker tape or anything that is long and skinny works really well for fractions with the linear model. It links strongly to number lines, which are hugely beneficial for students when they're learning about the idea of benchmarking and therefore building ideas of the size of numbers. So working with those streamers and then being able to physically fold them in half, see where a half is, then fold them in quarters, see where the quarter is. See how 1/4 is the same as the difference between 3/4 and 1 whole. So being able to manipulate is incredibly important with fractions, because fractions are relational. So unlike when we talk about whole numbers, which students understand as being a set quantity all the time, fractions are relative to whatever they are a fraction of, and that's a really difficult concept for students to understand. So even when we talk about the area model, which is the most straightforward of the models and the one that we use the most often, as teachers we make a fundamental mistake sometimes, and it's easy to do. We assume that students have that understanding at a level they need. Now, most of us have gone through a system that explains that learning takes place in a concrete, then a representational, then an abstract form. And unfortunately, a lot of us in today's society, where we can link to documents on Teachers Pay Teachers or on Twinkle or on any program that we have access to, most of those sites lead us to having worksheets. They have a printout that structures things. Now, I talk to my students about this quite a lot, and I think that for a lot of teachers, we need to really think about it. I can draw, let me draw a square. I'm not a very good square drawer. Let me draw a square. And if I'm deciding that I want to talk about quarters, and I draw my square and I shade, colour, whatever my quarter, that's a fairly straightforward representation. And what you'll find is most students will draw that representation every time you ask them to make a quarter. Now, the issue becomes later on when we want to talk to students about the idea of creating a common denominator in order to compare unlike fractions. So we've got 2/3, we've got 3/4, and we need to add them or subtract them or work out which is bigger. Students automatically go to this format with the squares. In order for them to find a straightforward and concrete way to represent and compare 2/3 and 3/4, they would be better off using a linear model and actually folding them into thirds and quarters and then comparing them, or when they come to adding or subtracting them, they would be better off to use thirds, for example, going in that direction, quarters going in that direction, and realizing that this is 3/4 and this is 2/3. because then they can see exactly how to get to those twelfths that allow us to add and subtract. But if their ability to visualize is only looking at those four squares within a square or four squares within a rectangle, they don't think of that. It is not part of their repertoire of visualizations. And so that's why when we go straight to working on paper, straight to working on a worksheet, for example, or on whiteboards, they can't do the most fundamental thing that we really need students to do when they're learning about fractions. They can't fold, they can't cut. So instead of starting off with those, and when I say starting off, I don't mean in year 1 and kindy and pre-primary. I mean every time that we teach fractions, at whatever year. And we know that students at some point through their process, many students start to believe that using manipulatives is a baby thing. And I think that's because we as teachers stop getting the manipulatives out at a certain point. We start going straight to abstract or straight to representation. And every new concept we teach needs to go back to concrete. Because the same as for us, when we want to learn about something, we don't want someone to just tell us about it. We want somebody to let us do it, to try it, to learn by failing and trying again. So one of the things I quite like at about year 3 or 4, when we're talking about this concept of fractions is, and I don't use A4 paper for this, I often use scrap paper cut down to something like an A5. But for this, let's look at an A4. I ask students to make me quarters. Fold your piece of paper into quarters. Okay. They quite like it. They fold it into quarters. There you go, miss, done. So then I say, okay, here's another piece of paper. Fold it into quarters a different way. And most students will be able to go, oh, okay, I can fold it that way. And while we're doing this, we talk about things like, how do you know that it's a quarter? And some students will be able to say, well, I know a quarter is a half of a half. Some students won't know. Some students will say, well, it's 1 part out of 4. Some will then go, oh, but it has to be equal. So usually someone will come up with this. I tend to do this in small groups because it allows each student to think about it by themselves. So I often use it during a maths rotation. And then this is the point where a lot of students start to struggle. They only think of a paper in one direction. Not all students. Some of them go straight to the next stage. But then eventually someone will go, oh, wait a minute. Maybe I can fold it the other way. I'll just grab 2 pieces of paper. And then we'll start to fold in here. But what you'll notice, and as you talk, let's ask students questions. Gee, all of your quarters are rectangles or squares. Do quarters have to be rectangles and squares? And then we start to see this. That's usually the point at which your second group will start to go, oh, I don't know what to do now. And then you'll find a lot of people will try again and they'll fold this way and go, oh no, that'll give me the same shapes I already had. So, one of my pieces of advice at this point would be, don't do the teacher thing and tell them the answer. Struggling is important. It's part of how they build the pathways in their brain that helps them understand. If they've been going for quite a while and they've tried and they've folded it this way, did you note that my pieces of paper were rectangles? Because they're year 3s and 4s, it's actually time for them to start realising that quarters work, or fractions work for any shape. And hopefully they've come across this before. But you'll find quite a lot, if they're anything like the students I've taught over the last 20 years, will try and make it a square because they know that they can cut a square into halves. And then they go, but what do I do with this end bit? This is where the learning is happening. This is where they are actually starting to go, oh, I know the rules of fractions, but I don't really know how they're applied. So, as we go, someone will eventually go from corner to corner. And actually doing this with a rectangle, it's amazingly tricky, especially if you're a year 3. So be patient because it will take a while. And I know some of you, while I'm doing this, are saying, this will take too long. I don't have the time. We've got to move on to the next topic. This will take a week if we do this with my kids. It will, but it's one of those occasions where you are better off spending the time at the beginning, because then everything that comes later will make more sense, it will go smoother, and you will not be fixing misconceptions all the time, because you will have dealt with them at the very beginning when it's easiest to stop them occurring. Now, I'll be honest, my folding was not perfect, I missed the corner, but so will your year 3s and 4s. And I say year 3s and 4s because I think if this is when you're teaching fractions, if you do it in year 3 and 4, year 5 and 6 will be much smoother. However, I often have to do this with year 5s and 6s who have not had this experience before. So at this point, I usually ask students how they prove that these are all equal, because they do not look the same. This is where students start to really think about the fractions. They start to say things like, but this was a half and then I cut it in half, so they must be quarters. That's a good start. They're starting to understand how to apply what they're doing. But the concept of proving, you can't prove unless you're on grid paper, in which case you've got a better chance. But if I draw this shape on a whiteboard, how can they prove that those shapes are the same? They would have to get something to cover up the area and then recover the other side. So they may need to get grid paper and cut it out, which could work. But with a piece of paper, they can get a pair of scissors and cut out this quarter here, and then try and fit it into this quarter here. And they may have to cut it into parts. But what that will do is start them understanding that a quarter is about how much space something takes up when you're talking about an area model. So this simple activity, it takes very little preparation. It takes very little work on the student's behalf. It's a lot of fun for them. Some of them do struggle with the thinking, but that's okay. That's part of the learning. And then we can start to say things like, well, what other ways could you make a quarter? And often at that point, I'll give them back one of their old sheets and say, is there a way that you could make a quarter now with more folds? And because then we can start to say, well, okay, if I fold it in half this way, I could colour in this part and it would still be a quarter. And so this builds the deep conceptual understanding we need of the area model that will help them as they move forward. The linear model, as I said, is usually best taught with streamers. And then we move on to, so if these are our concrete representations that we spend quite a while on, then we start to look at different ways to use that knowledge in different contexts. So for example, a task I set for my year 6s last week was a design task. It was an inquiry. And the inquiry was, I would like you to design a flag that has 1/3 red, 1/4 blue, and 2/5 yellow. Now, for any of us that are fairly good at adding and unlike denominators, you'll realise that that's 59/60ths of the flag will be coloured in. And I did that deliberately because that's a very quick way for students as they work through to start saying to you, and therefore telling you that they've understood it, oh, but miss, that's not the whole flag. There's a little bit left over. What colour should I make it? What should I do with it? And so as you're walking around, you can very clearly see if students have actually done what they needed. You also get to see misconceptions. So you get to see students who go, oh, well, I've done 1/4 of the flag. Now I'm going to do 1/3 of what's left. This is a misconception that needs addressing. The fractions are of the whole, not of the remainder. You will also find which students can understand unit fractions, those that have a 1 1/5 to 1/4, and those who are unable to take the next step to understanding non-unit fractions or multiple fractions. As you work your way through this, it's a really important process for students to struggle with this. And usually my instructions for this task are, it's not one flag. I want you to come up with as many flags as you can using those fractions. And because I am kind, I usually give them the dimensions of the flag as being 12 by 5. And this allows us to come back to this idea of the 5 will be able to be easily divided into 5 lines. So you'll get your fifths very easily. 12 is easily divisible by thirds and quarters. And so students who really understand fractions, when they have those dimensions, do not have to do a long algorithm to solve the problem. They quickly go, oh, 2 lines will be fifths. Oh, okay, 3 lines across, especially if you do this on grid paper. That will allow them to work out very quickly their quarters, fifths, and thirds. And then they go and demonstrate this understanding of the different ways that fractions can look by using the number of squares. When we work with the set model, which is the third model, realistically, the best way to do it is with objects. A box of little Lego, a box of little toys, dinosaurs, things like that, a box or a bag of marbles, anything that is actually physically able to be grouped and placed. And to help students with it, I often use a large circle to put their total amount in, and then either separate by colour or separate by a small circle so that they can say, well, what's in that section is 1/4 of the total. Once students are comfortable with those 3 models, moving on to understanding the constructs is quite straightforward, because the 5 constructs link beautifully to the 3 different models. I hope that was helpful. I will put some links below that link to some lovely sites that look at inquiry learning, and I will link to some articles that talk about the 3 models and why it's so important that our students are really, really familiar with them and are able to use the language of area model, set model, linear model, and are able to talk about fractions as more than just part of a whole, as part of a group, as part of a line, as not just the first part of a line, but any section of a line. That language will allow them, as they progress, to have the basis they need for fractional discussion and moving on to the more complex use of fractions that will come in upper primary, lower secondary, and through to the end of their schooling. Okay, I will look forward to seeing you next week. I hope this was helpful. See ya.